$179. That is the number that stops everyone mid-scroll in April 2015. A fully wireless, fully enclosed 3D printer for less than the cost of a decent pair of sneakers. At a time when the cheapest reliable printers on the market are sitting at $500 minimum, that price tag feels almost offensive. You see it and your first reaction is either this is brilliant or this is a scam. Now, for over 16,000 people around the world, that reaction turns into a pledge. Real money and real trust handed over to a small team most of these people had never heard of before. And what happens next becomes one of the most talked about disasters in crowdfunding history. Behind that price tag is the Tiko team, a small group of designers and engineers based in Canada. Their idea is straightforward. Strip away everything expensive, design a 3D printer completely from scratch, and sell it at a price point nobody in the industry would dare attempt. And when I say nobody was attempting this price, I mean the gap between what they were asking and what everyone else was charging was enormous. You are about to meet their product. This is the Tiko. The Tiko does not look like a typical 3D printer. Most printers at the time are open frame machines. Exposed metal rods and visible electronics with moving parts right out in the open. They look like something assembled in a university lab. The Tiko looks completely different. It has a smooth, clean, single-piece shell. Everything is packed inside that sealed body. An LED light glows inside the enclosed print chamber. It is compact, lightweight, and completely wireless. And when I say it looked different from everything else on the market, I mean genuinely, totally, visually different. So how does it work? Inside that sealed shell is a 3-arm delta system. 3 arms work together to guide the print head around the build area with precision. This kind of mechanical setup is used in industrial machines and is known for accuracy and speed. The whole printer weighs just under 2 kilograms. It has a built-in safety sensor that shuts the machine off if someone bumps it during a print. And the filament, which is the plastic material that gets melted and shaped into objects, is standard off-the-shelf material. You do not need any proprietary spools. You can buy filament from any brand, anywhere. Well, the pitch is hard to argue with. A wireless, enclosed 3D printer for under $200, at a time when machines from established brands cost 5 to 10 times that price. The Kickstarter campaign goes live in April 2015, and people react fast. Now, within weeks, the campaign is trending hard. Backers from around the world start pledging. Makers and engineers and art teachers. Parents who want to print toys with their kids. Small business owners looking for affordable prototyping tools. Tech enthusiasts who just want in early. Word spreads across forums and YouTube channels and 3D printing communities everywhere. You can practically feel the momentum just by scrolling through those early comments. Everyone is asking the same question. Is this real? Is this actually going to happen? The answer, according to the campaign page, is a loud and confident yes. The Tiko team writes that they face no design risk, that they have already worked through the hard problems, that backers can sit back and relax because they are going to get everything they hoped for, and then some. But it is not just the marketing text that wins people over. The campaign videos show a physical working prototype. The printer runs live on camera. The Tiko team explains the Delta system. They talk about the unibody frame like it is their greatest accomplishment. Everything looks real and everything looks ready. So the money pours in. By the time the campaign closes, Tiko has raised nearly $3 million from over 16,000 people. It becomes the second most funded 3D printer campaign in the entire history of Kickstarter. Now, let that number sink in. Nearly $3 million. Over 16,000 individual people, most of them putting in somewhere between just under $100 and $179, trusting this small Canadian team with real money because they believe in this machine. I want you to hold on to that number, because it becomes very important later. Well, the press picks up on it fast. 3D printing publications write features. Tech blogs talks about the pricing like it represents something significant for the whole industry. The idea that a fully wireless, fully enclosed 3D printer can exist at this price point generates real excitement far beyond just the backer community, and the Tiko team looks like they are handling the attention well. Regular updates go out and backers stay engaged. The comment sections fill up with people sharing what they plan to make. Replacement parts, custom toys, architectural models, art pieces. The list seems endless. If you scroll those comment sections today, you can still see how real the excitement was. But what nobody is talking about yet is what actually happens when 16,000 of these printers have to work. Once the campaign closes, the money is in. The original plan is to start shipping by November 2015, roughly 6 months after the campaign ends. The Tiko team says they are ready and manufacturing is sorted. Everything is on track. So November comes around and nothing ships. But the backer community does not panic, at least not yet. These are people who backed a hardware startup on a crowdfunding site. Delays happen on these kinds of projects all the time. The Tiko team posts an update. They need more time to get the manufacturing right. Backers respond with patience. The mood stays warm. But you are talking about a community that genuinely wanted this thing to succeed. December passes, then January. By spring of 2016, the updates from the Tiko team grow thinner. More reassurances with fewer concrete details. Some backers get louder in the forums. Others keep waiting quietly. Well, the people pushing for answers are not getting much to hold on to. The Tiko team keeps saying the machine is coming and to just trust the process. Now, about 8 months after that first missed deadline, units finally begin shipping in the summer of 2016. And the first reactions from people who receive their printers are mixed but not completely catastrophic. Some backers post unboxing videos. The machine looks good in person. The build quality is actually better than many expected. For something at this price point, the shell is solid. The design holds up physically. When you open a box after waiting over a year, you want to see something that works. And at first glance, some backers feel a wave of relief. You can hear it in some of those early posts and videos. It is real, and it actually arrived. Maybe the long wait was worth it. A handful of early receivers report promising results. A few share photos on Reddit. Comment sections fill up with cautious optimism. The story at this point looks like a project that had a rough start and painful delays, but got something real into people's hands. So it seems like maybe Tiko pulls it off. Well, it does not. Before the collapse, it is worth understanding what this machine was really built on. The Tiko team designed the Tiko around one central idea. Keep manufacturing as simple as possible. Reduce the part count. Use the sealed unibody frame to lower assembly costs. Price it at a level nobody else was willing to go. And trust that the design would hold up under real conditions. But then people start actually using these machines. So here's where everything falls apart. The first real wave of user reports is brutal. Wi-Fi connections fail and filament keeps snapping mid-print. And when backers open their shipping boxes, they find the delta arms, the internal metal rods that guide the print head, already bent and not from use, from how the printers were packed. Whoever assembled those boxes jammed the internal tubes and wires underneath the arms. By the time you open your box, the machine is already damaged before you have ever turned it on. Now, bent arms are frustrating but potentially fixable. But what is not fixable without a complete redesign is the motor problem. The Tiko was built with a type of a small motor that has roughly 1/10 the torque of the motors used in standard 3D printers. Not slightly underpowered, not even close to what the job requires. These motors cannot generate the force the Delta system needs to operate properly. So the print head shifts. Layers come out misaligned. Prints fail over and over. And when I say they fail constantly, I am not talking about occasional hiccups. I am talking about a machine that cannot reliably do the one thing it was built to do. But there is still another problem. And this one might actually be worse. The sealed unibody frame, the most talked about feature of the whole machine, turns out to block something critical. Calibrating a 3D printer normally means sliding a thin piece of paper between the nozzle and the print bed to set the right starting gap. With the Tiko, the sealed frame blocks access to the print bed entirely. You cannot get your hand in there. So every single print starts from a position that might be wrong, and there is nothing you can do about it without cracking the whole unit open. Well, the prints that do come out show even more problems. Print times are absurdly long, over an hour for a small simple object at basic settings. Output quality is inconsistent and layer lines shift constantly. One reviewer says they feel like they wasted their money and cannot recommend the printer to anyone. So what does the Tiko team do? They push software updates. Firmware patches and more updates keep coming. No software patch can give underpowered motors more torque. No firmware update is going to open up a sealed shell so you can calibrate the print bed. The hardware problems are built into the hardware. Code is not going to solve that. Now, on top of everything else, backers start receiving an unexpected charge. $55 for shipping, billed after the campaign has already closed. People who pledged at the early bird rate of just under $100 are now looking at a total well over $150, and they still do not have a printer that works. But here's the detail that really burns. When backers started raising concerns about the delays and the problems, the Tiko team took 2 full months to publicly say anything. 2 months of silence. And during that period, the frustrated backers who were speaking up were described internally as fools. By early 2017, the money is gone. The company announces it is going on standby. Mass layoffs hit the Tiko team. And in November 2017, Tiko officially shuts down forever. So here are the final numbers. Out of 16,500 backers, only around $4,000 ever received a printer. Roughly 12,000 people, more than 72% of all backers, got absolutely nothing. No printer, no refund, not a single dollar back. If you were one of those 12,000 people, you never saw a refund, and you have never seen one since. The total financial loss to backers crossed $2 million. Kickstarter's terms protect the platform, not the backers. With the company bankrupt and gone, there was no path to recovering any of it. Tiko shut down officially in November 2017 and never came back. The money is gone. No refunds and no second chances. Just 12,000 people who trusted a promise that was never kept. So, what do you think about this one? Have you ever heard of the Tiko before, or maybe even considered backing it? Let me know in the comments down below. And if you want to see more videos like this, consider subscribing to the channel. Thanks for watching, and I will see you on the next one.